Hello guys, welcome to an Academic KCET YouTube live session. Myself Sharif. In this particular video, we will discuss the PYQs of matrices and determinants part 3. Part 1 and part 2, we have done some 54 questions. Yeah, 53 questions I have done. I'll start with question number 54. Before I start, guys, please do subscribe and enable the bell icon so that you get notification for all the classes. And if you've already subscribed, please do share this video. At the below the link, there's a description. Please go through the description. Right, let's start, guys. Question number 54. See, if it is a true for x, then it will be true for obviously any value of x, right? So I need not do the problem. If it is true for x, then it's obviously true for any value of x. I'm going to substitute x as 0. X is 0, y is 1, and x is equal to 0, y is 1, and z is equal to 2. Or you can put x as 1, x is 0, y is 1, z is 1 as well, right? Now if I substitute here, this is determinant of 0 plus 1 will be 1, 1 plus 2 is 3, and z plus x is 2 plus 0 is 2, and then you get this is 0, 1, 2. The last x minus y, this is minus 1, y minus z is minus 1, z minus x is 2. If I expand, delete first row, first column, you get 2 plus 2. Minus 3, delete first row, second column, 0 plus 2. First row, last column, you get 0 plus 1. So this is 4 minus 6 plus 2. I get 6 minus 6. Answer will be equal to 0. Answer is option A only. So if it is true for x, then obviously it is true for any value of x. So use this technique. I have done this in part 1 and part 2 as well. Okay, let's start. Let's move to the next question. Question number 55. This is of the form A into adjoint of A is equal to determinant A into I. This is of the form A into adjoint of A is equal to determinant A into I. If I compare, determinant A is equal to 5, right? Determinant A is equal to 5. N stands for order of the matrix. It is given in the question. It's a matrix of order 3. That's why N is equal to 3. Determinant of adjoint A. Determinant of adjoint A is equal to determinant A power n minus 1. N stands for order of the matrix. Determinant A is 5. So this is 3 minus 1. I get 5 square, which is equal to 25. Answer is option B. Question number 56. Again, determinant of adjoint A is equal to determinant A power n minus 1. N stands for order of the matrix. It's a matrix of order 3, so that's why n is equal to 3. Determinant A is equal to 8. 8 to the power of 3 minus 1, which is 2. 8 square is 64. Answer is option B only. Is it clear, guys? I'm just using the result. Determinant of adjoint A is determinant A to the power of n minus 1. Question number 57. Alright, now good question. Now listen. Determinant of adjoint A, determinant of adjoint B, which is there in the denominator. Determinant of adjoint of B is equal to determinant of adjoint of B is equal to adjoint A. That is already given in the question. B is equal to adjoint A. Right, now all the chapters are important, right? All the chapters are important. Determinant of adjoint A is determinant A power n minus 1 the whole square. N stands for order of the matrix, right? N is equal to 3 because it's 3 by 3 matrix. This is determinant A power 3 minus 1 the whole square. This is determinant A power 4. Right, now I'll find the value of determinant A. Determinant A is equal to 3 into delete first row, first column, you get minus 3 plus 4. Plus 3 into delete first row, second column, you will get 2. Right, and delete first row, last column. Delete first row, last column, you get minus 2. So this is 3 plus 6 minus 8. which is equal to plus 1. 1 power 4 is 1. So determinant of adjoint of B will be 1. Now if I substitute here, this is determinant of C, denominator is 1. C value is equal to 5a, right? Determinant of 5a, if you take 5 outside, it is 5 power n into determinant a. It's a matrix of order 3, so that's why 5 cube determinant a is 1, which is equal to 5 cube is 125. 5 cube is 125. Answer is option B, option A. Good question, guys. It's a COMEDK question. Let's move to the next question. Question number 58. In complex numbers, we have done. In fact, recent papers they have asked cube roots of unity. Cube roots of unity is 1. What's the doubt, Sagar? Sagar, you find out determinant of adjoint of B. Determinant of adjoint of B. Adjoint of B is already given adjoint of A. Determinant of adjoint A is determinant A per n minus 1 the whole square. This is the formula. N stands for order of the matrix. Order of the matrix is 3. So that's why determinant A per 3 minus 1 the whole square. Determinant A per 4. You expand this determinant. Just now I found out the value. It will be 1. If you substitute, you get 1. And C value is 5a. If you take 5 outside the determinant, it is 5 power n. N stands for order. N is 3, right? Now you substitute, you get 125 only. Is it okay? Go through the recording once. It's simple. I have done in all the steps. I have done the problem in a very simple method, step by step. Is that okay, Sagar? All right. Now this you've done in complex numbers. 19 paper, 18 paper also cube roots of unity questions are there in complex numbers. Cube roots of unity is 1 omega square, right? And omega cube is 1. Omega cube is 1, and we know 1 plus omega square is 0. Okay, now I'll take this as determinant of. I take determinant of. I add this change C1 to C1 plus C2. Add the first column and the second column. If I add the first column and the second column, this is 1 plus omega square. This is omega square. And then again this is 1 plus omega square. Second column is omega square minus omega and omega. Last column is omega square and omega square. 1 plus omega square is 0. Okay, this is omega square. 1 plus omega square is 0. Right? In the second row, I take omega common. Third row also you take omega common. Second row you take omega out. Third row also you take omega out. This becomes omega minus 1 and 1. This is 1 omega and omega. Right, now this is equal to omega square. 0 multiplied by a number is 0. This is minus omega. Delete first row, second column, you get omega cube. Okay, plus 1. Delete first row, last column, you get omega square. Omega square into omega cube is 1. So you get minus omega plus omega square. Right, now if I multiply, I get minus omega cube plus omega power 4. Omega cube is 1. Omega power 4 can be written as omega cube into omega. Omega cube is 1. So you get 1 plus omega. That is omega minus 1. Answer is option B. Right, let's move to the next question. See, I'm supposed to find what's the value of Z. Don't use matrix method, it takes a lot of time. A into X is equal to B. Nikhil, you go through the basics of integration. F of minus x is equal to f of x. That is called an even function. f of minus x is equal to minus f of x means then it is called an odd function. Right, so this is ax is equal to b, a is equal to 1 1 1 1 2 3 1 3 4. Matrix x is equal to x y z, and b is equal to matrix 7 16 22. Multiply first row first column x plus y plus z. First row second column you get x plus 2y plus 3z. First row third column will be equal to x plus 3y plus 4z is equal to matrix 7 16 and 22. Okay, now if I equate them, x plus y plus z is equal to 7, you call equation 1. X plus 2y plus 3z is equal to 16, and x plus 3y plus 4z is equal to 22, call equation 3. Right, equation 2 minus equation 1, if I subtract, you will get this as y plus 2z is equal to 9, and equation 3 minus equation 2, if you subtract, you will get this as y plus z is equal to 6. Let's call equation 4, call this is equation 5. Equation 4 minus equation 3, if you minus, you will get z is equal to 3. So value of z is equal to 3. You understand, guys? You don't use matrix method. It takes a lot of time. Alright, let's move to the next question. Question number 60. I'm supposed to find out what is a power 4. A power 4 can be written as a square into a square, right? A to the power of 4 is a square into a square. Okay, first I'll find out what is a square. Yeah, Gaurav, you're right. Yes. A square is equal to 0 0 1 0 1 0 1 0 0. Again 0 0 1 0 1 0 1 0 0. First row first column will be 1, first row second column will be 0, first row third column is 0. Similarly 0 1 0, here I get 0 0. Oh, second last row last column, yes, 0 0 1. So this is a square is equal to I. A square is I, a power 4 is also I. Answer is option A. Okay, question number 61. If A and B are square matrices of same order and B is a skew symmetric matrix. Skew symmetric matrix means it should be equal to negative of its own transpose. B transpose is equal to minus B according to the question. Now A dash BA whole dash is equal to reversal law of transposes. AB whole dash is equal to B dash into A dash. So this is A dash B dash A dash of dash. So this is A dash B dash and A. B dash of B dash B transpose is minus B, right? So this is A dash B transpose is minus B and A. So you're getting negative of its own transpose. That is, I'm getting A dash B A whole transpose is equal to negative of its own transpose. So this means that A dash B A is skew symmetric because I'm getting negative of its own transpose. Isn't it, guys? Getting negative of its own transpose. That's why this is a skew symmetric matrix. Answer is option B. Okay, question number 62. This was asked in 2020 paper. If I shift on the right side, this becomes 2, matrix A is equal to 2 1 3 2 inverse, okay, into this is I, 1 0 0 1 is I. If I find out A inverse, 2 1 3 2 I'll take. A inverse is equal to 1 by determinant A into adjoint A. Determinant A is anyways 1. Adjoint is interchange the diagonal elements, change the sign of other elements. So this is 2 minus 1 minus 3 2 into I. Right, you get back the same thing. So this is 2 minus 1 minus 3 and 2. That is last option D. Okay, question number 63. Even this was asked in 2020 paper. See, if I take suppose f of 0, you get determinant of 0 AB minus A 0 and C. You get minus B minus C and 0. Alright, yes Varun, right? So it's a skew symmetric matrix, right? Determinant of a skew symmetric matrix of odd order is 0. Otherwise, even if you expand, you get 0 only. Alright, f of 0 will be 0. Answer is option A. Right, let's move to the next question. Question number 64. See, even this question is in AP. This question is this 2020 question. I told you whenever the arrangement of numbers are in AP, then the value for determinant is always 0. If it is given in the question that A1, A2, A3 up to AN is in AP, then what's the value of this determinant? Obviously, this A1, A2, A3, A4, A5, A6, A7, A8, A9 all are in AP, right? So determinant should be equal to 0. Yes, Varun, right? So this is equal to log to the base C of log E is 1. Log 1 to any base is 0. Answer is option A. Okay, because log E to the base C is 1 and log 1 to any base is 0. Answer will be equal to 0. Okay, I repeat, if the arrangement of numbers are in AP, let's say this is 2022, 2023, 2024, 2025, 2026, 2027, 2028, 2029, this is 2030. If the arrangement of numbers are in AP, determinant is always equal to 0. Right, let's move to the next question. The determinant A is 5, right? And it's a square matrix of order 3, so this is n is equal to 3. Determinant of A into adjoint of A. We know that A into adjoint of A is equal to determinant A into I, right? So this is determinant A into adjoint of A is equal to determinant A into I. Determinant A is 5. 5 into I. 5 you take outside the determinant, it is 5 power n into determinant I. Determinant I is 1. N stands for order of the matrix, so you get 5 cube. 5 cube is 125. That is last option D. Yes, Varun, right? Okay, question number 66. If I multiply this, first row, first column, you get minus 2x plus 5y. First row, second column, second row, first column, you get 3x minus y is equal to, this is 3 minus 2, and then you get 9 minus 4. If I equate, you get minus 2x plus 5y is equal to 1. So this is 3 minus 2, 1 and 5 only. Yes. And then you get minus 3x minus y is equal to 5. I'll multiply this by 5. Minus 2x plus 5y is equal to 1. You multiply by 5, you get 15x minus 5y is equal to 25. It will cancel. You get 13x is equal to 26, x is equal to 2. There's only one option where you have x is equal to 2, right? Or you substitute in the equation minus 2x plus 5y is equal to 1. If I put x is equal to 2, you get minus 4. Yes, Savarun, right? You get 5y is equal to 5, y is equal to 1. X is 2, y is 1. Alright, it's a simple question only. Question number 67. Okay, now listen. If the product of matrix B with matrix A has the inverse C, that is product of matrix B with matrix A, product of matrix B with matrix A has the inverse C, that is C inverse. If I take inverse both the sides, you get AB BA whole inverse. BA inverse is equal to C inverse of inverse. So this is A inverse into B inverse is equal to C inverse of inverse is C. Right, I'm supposed to find out what is A inverse, right? Okay, now if I suppose operate B on left, operate B matrix B on right. If I operate B on right, follow carefully guys. A inverse into B inverse into B is equal to C into B. Did you understand? If I operate B on the right, because A into B is not equal to B into A, you can't multiply wherever you want. I'm supposed to find what is A inverse. Okay, I'm supposed to find out what is A inverse. If I operate the B on right, so you get B inverse into B is equal to CB. B inverse into B is I is equal to C into B. C into B is C is minus 1, 0, 1, 1, 1, 3, and 2, 0, 2. That order is very important because C into B is not equal to B into C. Into you have for B is equal to 2, 6, 4, 1, 0, 1, and then minus 1, 1 and minus 1. A inverse into I is A inverse, right? Now if I multiply first row, first column, minus 2 plus 0 plus minus 1, that is first row, first column. First row, second column, minus 6 plus 0 plus 1. First row, third column, you get a minus 4 plus 0 minus 1. Second row, first column, second row, first column, you will get this as 2 plus 1 minus 3. Second row, second column, you will get this as 6 plus 0 plus 3. Second row, last column, you will get this as 4 plus 1 minus 3. Third row, first column, you get 4 plus 0 minus 2. Third row, second column, you will get this as 12 plus 0 plus 4 plus 2. And last row, last column, you get 8 plus 0 minus 2. Right, now if I simplify this, get a final matrix as minus 3, minus 5, minus 5. Okay, and then you get this as 0, 9, 2. Then you get 2, 14, and 6. Last option D. Sir, okay, yes, Varun, right. Right, let's move to the next question. Question number 68. If I suppose add all the columns, if I change C1 to C1 plus C2 plus C3. If I add all the columns, this is alpha plus beta plus gamma, right? This is also alpha plus beta plus gamma, right? Even this fellow is alpha plus beta plus gamma. This is beta, gamma, alpha, beta. Isn't it, guys? This is of the form ax cube plus bx square plus cx plus d is equal to 0. See, actually, sum of the roots, if I compare a is equal to 1, b is equal to 0, c is equal to a square, d is equal to b. This is equal to 0, right? Sum of the roots is minus b. So alpha, beta, gamma are the roots. Sum of the roots is equal to minus b by a. So I'll take this alpha plus beta plus gamma, I'll take out. Or you keep as it is. Why? Keep as it is, no issues. Sum of the roots is minus b by a. B is 0, right? 0 by 1, which is equal to 0. You get determinant of 0, 0, 0. Then you get beta, gamma, alpha. Then you get gamma, alpha, beta. All the elements of first column is 0. It should be 0. You understand, guys? Can I move to next question? Okay, question number 69. You get determinant of change R1 to R1, change R2 to R2 minus R3. If I change R2 to R2 minus R3, this 4 I'll take outside, this is 1, 1, 1. R2 minus R3, if I subtract, you get A plus A inverse the whole square, minus of A minus A inverse the whole square. Okay, A plus B the whole square, minus of A minus B the whole square is equal to 4AB. You get 4A into 4A inverse, which is equal to 4 only. Okay, so if I substitute, this is equal to 4, 4 and 4. 4AB means I'm getting 4. Similarly, this will be 4, this will be 4. Right? Two rows are same. Answer will be equal to 0. Answer is option A. Right? Jack, this is not physics pala. This is an academy. Okay. Question number 70. If A and B are two sets containing 2 and 4 elements, respectively, number of subsets of A cross B. If A is having 2 elements, B is having 3 elements, obviously A cross B we should have A is having 2 elements, B is having 4 elements. A cross B should have 8 elements, right? So this fellow will have 8 elements. Right, then the number of subsets of A cross B having 3 or more elements. So, greater than or equal to 3. So this means that 8C3 plus 8C4 plus 8C5 plus 8C6 plus 8C7 plus 8C8. Right, there was a similar question in 2020 as well. I can write this as 8C0 plus 8C1 plus 8C2 plus 8C3. Okay, and so on up to this is 8C8. And now I'm going to subtract. Minus this is 8C0 plus 8C1 plus 8C2. Okay, sum of all binomial coefficients is 2 power n. So this is 2 power 8. I'm using the result NC0 plus NC1 and so on up to NCn. Sum of all binomial coefficients is equal to 2 power n. Minus 8C0 is 1, 8C1 is 8, 8C2 will be 8 into 7 upon 2 into 1, which is equal to 28. Okay, so this is 28. 2 per 8 is 256 minus, right? If you add this, you will get this as 28 plus 8, 36 plus 1, 37. Okay, so you get 211. 256 minus 37 minus 37 will be equal to 9 plus 7, 6, 4, 1, 219. Sorry, you get 219. Answer option D. This is clear, guys. Question number 71. There was a similar question in 2020 as well. P is equal to adjoint of a 3 by 3 matrix. So P is equal to adjoint of A. Right. Now determinant of P is equal to determinant of adjoint of A. Determinant P value, if I find out here, this is P, right? Determinant of P, determinant of adjoint A is determinant A power n minus 1. N stands for order of the matrix. So n is equal to 3. So determinant of P is equal to determinant A is 4 whole to the power of 3 minus 1. This is 1 into first row, first column. 12 minus 12 is 0. Minus alpha. Am I finding determinant P? 4 minus 6 plus 3 into delete first row, last column. You will get 4 minus 6 is minus 2 is equal to 16. This is 0. You get 2 alpha minus 6 is equal to 16. 2 alpha is equal to 22. Alpha is equal to 11. Right, answer is option A. Question number 72. We have done this question, guys. Today's class only we did. Z is equal to 3, x plus y plus z. We did a similar question, no? 1 minute. We did a similar, exactly same, I guess. Where z equal to 3 we got. Yeah, same problem. Question number 59 we did. Today's session we did question number 59. 1, 1, 1, 1, 2, 3, 1, 3, 4. So same question, z is equal to 3. Question number 59 in this particular session we did question number 59. Z equal to 3 only. Right, let's move to the next question. Okay, even this question I did. Even this question we have done in this today's session. Question number 74. If I find out determinant of A, determinant A is equal to 1 minus, this is log A to the base B into log B to the base A. Determinant A is equal to 1 minus, this is log A and by log B into this is log B upon log A. Log A will cancel, log B will cancel. Determinant A is equal to 1 minus 1. So determinant A is equal to 0. Right, determinant A is 0 means answer is option A. Okay, and in this A into C is equal to given, you should find out matrix C, right? I'll operate A inverse on left. Operate A inverse on left. So this becomes A inverse into AC. Alright, A inverse into A into C. Don't worry, matrix multiplication is associative. A inverse into this is 19, 24, 37, 46. A inverse into A is I. I into C is equal to, A inverse is equal to 1 by determinant A into adjoint of A. Determinant A is equal to 15 minus 8, which is equal to 7. 1 by 7. This is 1 by 7. Adjoint is interchange the diagonal elements and change the sign of other elements. So this is 5 minus 2 minus 4 and 3. Okay, and then see, this is 19, 24, 37, 46. I into C is equal to C 1 by 7. Now you multiply first row, first column, you get 95 minus 74. First row, first column, first row, second column, you will get this as 120 minus 96. 46 into 2, 92. Second row, first column, you get 14 into 19 is 76. 37 into 3 is 111, triple one. Then you get minus 96 plus 46 into 3 will be 138. If I simplify this, you will get 21, 28, okay, 35 and 42. If you divide by 7, this will be equal to 3, 4, okay, and then 5 and 6, 3, 4, 5, 6. 3, 4, 5, 6 answers option C. Right, I'll stop here, guys. We'll continue with this in the next part. All right, and then please do subscribe and enable the bell icon. And if you already subscribed, please share this video, guys, and go through the description below. All right, and I will log in for after 15 minutes or something. In my next session, I will start with my 3D geometry. Last part is there. 21, 22, 22 KCET questions are there, and few questions left out of 3D geometry. We will discuss that session. Thanks for joining, guys. Thank you all, guys.